Hello, and welcome to the session There's More to a Product Than Functionality. I wanted to add, and why everyone should care about this, but that actually made it too long for the slide. In this session, I'm going to start with an introduction to me and why I'm interested in this topic, then go over how the session will work, describe what the issue is, and talk a bit about some of the tools and techniques that you can use to address this issue. We'll end up with some questions and discussion on the topic. I do want to say that this is an introductory session, so I'm not going to go into too much detail, but really give you more of a broad overview. So, who am I? I'm Chris Cooper-Bland, and I work for Endava as Group Head of Architecture, which means I'm involved in growing our capability in this area, and I also get involved in client projects, mainly in the banking and financial services space, but not just this. So I've worked in IT now for over 30 years and had quite a large number of roles, and these have really driven my interest in this topic. My very first IT job was working for the Metropolitan Police Service on a parking tickets project. And this was introduced by an act of Parliament, and they suddenly decided they were going to deliver it 6 months early. The real focus on the project then was just get it live. What's the minimum functionality we need to go live with? Which meant that everything else just went by the board. And strangely, no one really cared if their parking ticket wasn't followed up. If there was a problem with a particular ticket, we would just delete a batch of 50. And we never once got a complaint from the public about not being fined. So following that, I moved to BACS, who handled the UK direct debit and direct credit system. This was something completely different. It was all about volumes, large volume transaction processing, peak days, absolute correctness. You had to be able to test the system. And since then, I've been involved in lots of organisations with a whole range of varying needs between these two extremes. And what I have observed, if you only pay attention to functionality, problems will ensue. Of course, what a product does, its functionality, is important. After all, this is what will provide the business value. There is a lot of focus on how to capture the functionality, how to describe personas, writing the perfect user stories, backlog refinement, story prioritization to deliver business value. And this is all great, but we're missing something. In Agile, the role of the product owner is key. They are expected to understand customer needs and prioritize the work. Of course, most will focus on functionality above other factors. Let's explore this a little bit using a metaphor. We want to launch a new product, the River Transversal Product, or RTP. We have a simple story. As a traveller, I want to cross a river to get to the other side. This is our minimum viable product. And here we have task steps on Exmoor, which I always thought was 3,000 years old. But when I was looking for this picture, the internet told me that it might date from the Middle Ages, which I have to say was a bit disappointing. But we also have some other people we need to keep happy with our River Transversal product, people with boats. We have a new user story. As a boat owner, I want to sail up the river. And this is the Leeds Bridge, built in 1870. So now we've decided we want to go international with RTP. We want to break into the US market. Of course, everything is bigger in America. So as a traveller, I now want to cross a big river. So we built a lovely suspension bridge. Fantastic. But this is the second release of this bridge, as I'm sure some of you already know. Of course, the first release didn't go quite as planned.
Tacoma Bridge, Washington, opened only a few months ago, was built at a cost of over $6 million. But misfortune overtakes the great structure. These are some of the most amazing pictures ever recorded by a newsreel. The actual collapse of the world's third largest suspension bridge. Finally, the swinging road and the suspension cables give way and plunge into the water below. Fortunately...
So they didn't factor in the effect of wind and the effect of turbulence. In fact, the wind speed that day only reached 67 kilometres per hour, or 42 miles per hour in old money, when the main span of the bridge started to oscillate wildly. And I mean, that really is a factor that should have been considered. But didn't you just love that guy with the pipe just sort of calmly walking off the bridge? So, what's the issue for us in the IT world? We rarely get such dramatic footage of an IT failure as the Tacoma Narrows Bridge, but LinkedIn had a huge data breach where they saw data associated with 700 million of its users posted on a dark web forum last year. That's, of course, a huge confidentiality and security problem. There's been some quite interesting footage of the Galaxy Note 7 batteries catching fire and exploding, which of course is a safety breach. A few years ago, Google suspended sale of its smart glasses because they had a usability problem, and basically people wearing them just looked daft and didn't want to buy them anymore. At Indaba, we've had a few occasions where a client has come to us and asked for a proof of concept, and we've provided a proof of concept, which is, demonstrates the functionality they want, and then suddenly, against all advice, they want to go into production with it, and that has led to some issues around particularly scalability and performance. And some of you will remember the day the UK census information for 1901 was launched, and it crashed on the first day after 1.2 million access attempts. The expectation was that nobody really would be very interested in it, only a few sort of geeks, but it had been announced on the Today programme on Radio 4, and suddenly lots of people were interested in it. It just wasn't able to scale appropriately. The common factor in all these failures is that they didn't pay attention to all of the requirements of their products. They focused too much on the functionality and ignored one or more of what we call the quality attributes. I know you're all familiar with them. Sometimes we call them NFRs or ILITs. They include things like performance, usability, reliability, security, the factors that cause the failures in the examples we've just previously discussed. So let's briefly take a step back and look to see where they fit in context. This is a sort of slide you would see in a course on requirements management, for example. So requirements can be classified into three main areas. We have the functional requirements, what the system is expected to execute, the features, epics, stories, etc. recorded in backlog. Examples of this would include processing payments, ordering of shopping, streaming a film, whatever. The quality attributes, focus of what we're talking about here, sometimes called non-functional requirements. These are really the behaviours or the characteristics the system displays. And examples of these would be handling 5,000 transactions per second, or being available for 99.99% of the time. And then we have constraints. Sometimes quality attributes and constraints can be confused, but there is a subtle difference. Constraints are really things that limit the design choices of the solution, hence they act as a constraint. Whatever solution we propose, this constraint must be respected. Usually the choice has already been made by an organisation, or they might even be external factors. So a common example of this that you might see is a technology choice that's already been made. Like, we want a cloud vendor, we've chosen Azure over AWS, for example. And also, things like the laws of physics fall into this as well. So what does Wikipedia say about quality attributes? And this type of definition is common across ISO standards as well. It says that within systems engineering, quality attributes are realized non-functional requirements, and they're used to evaluate the performance of a system, sometimes called architecture characteristics or abilities. There are usually architecturally significant requirements that require architects' attention. But I really had two problems with this. Firstly, the phrase used to evaluate the performance of a system. That's really very late if you're using these to evaluate the performance. They need to be used to drive the fundamental design decisions about how the solution is shaped. For example, if I have a high availability requirement, I need to think about this from the very start, or it's going to get very expensive very quickly. I'll be talking more about this later. And secondly, it says here, they require the architect's attention. Well, that's just not enough. They need to be of interest to everyone, not just of interest to the architect. So what do you actually see when you bring up the subject of quality attributes in the initial discussions about a product with business people? And it's really sort of a number of tendencies that you'll typically see. Sometimes there's no clue, rather a lot of embarrassed silences, and people looking at each other in a slightly panicked way, obviously just don't know the answer. Or sometimes you see a list with lots of different types of quality attributes on it. And yes, we want that, but with no real measures or justification. Or sometimes you get a very, very long list with no idea of priority. And this, again, doesn't help. We need to find a way of focusing on the important stuff and getting the right people involved in the conversation so that we can understand what it is that we need to be working on. Of course, we need a balance between the functional scope, the cost, and to deliver in an acceptable time frame. And now we have to factor in the quality attributes as well. This means that the quality attributes need to be appropriate for the business needs. If time really is the most critical aspect, QAs may be secondary. An example of this is when we had to develop a game for the 2012 Olympics. There was no need for maintainability. Reliability and availability were definitely secondary. There was no security, because no real stringent need for security because there was no login or data captured. But if it wasn't delivered on time, if it was late and missed the Olympics, it had zero value. At the other extreme, for example, payment systems, they need to be correct, they need to be secure, they need to be available, and to be able to handle the appropriate volumes. So one of the big dangers of focusing on quality attributes is that you can begin to over-engineer the solution. And this is why you have to focus on the important aspects to make sure that you deliver in an effective way. So, what can we do about this? First of all, we group the quality attributes together based on where they represent the same sort of perspective or focus area. And we put this on a mind map because this helps manage the problem more easily. And I have to say, this isn't a scientific analysis, but it's intended as a tool to help. We've identified 6 areas here. There can definitely be a debate as to whether this is the right number or the right areas, but this level of detail seemed to help with constructive conversations. So, at a high level, the quality attribute perspectives are development and change. So this is really looking at how we build the system, how we maintain the system once it's live, how we test it, those sorts of things. Then there's the business focus area, and these are really the key concerns of the organisation which owns the system. So this is sort of how dynamic do we want the product to be, how often is it going to change, how long is it going to live, for example, and also in that we've included financial aspects, so the total cost of ownership and also cost of development, which is of course important. Then we have the runtime aspects, and these sort of focus on how the system's going to run during its operation. So things like availability, reliability, all those sorts of things. Then we have the user perspective. So this is aimed at making the system easier to interact with. So, making it usable, making it learnable, making sure it works for people with accessibility needs, those sorts of things. Then, of course, we have security. This covers all aspects of security, both protecting the data and protecting the system from unauthorized use or unauthorized access or hacking or any of those sorts of things. And then we have safety, and this is particularly needed for certain types of system which could potentially cause damage, injury, loss of life. And I have to say this is a new area for us. It's not an area that we've focused on extensively in the past, because not many people actually get physically hurt by payment systems that go wrong. However, these groupings do allow for our focused conversations to be held with the right stakeholder groups. And of course, each of these perspectives expand out. I'm going to go on and describe that in the next few slides. So we're going to look at each of the areas in a little bit more detail, not in great detail, or we might be here all afternoon, but just touch on some of the key points. So when we look at the business focus perspective, this again breaks down into a number of areas. We have sustainability, and these are really important issues for the product. How much change do we expect it to undergo, and how quickly are those changes going to be made? Are we looking for rapid, continual development of the product, or do we expect it to be a little bit slower? Maybe typically a system within a business might have slower change than a customer-facing system. Are we producing something which we expect to be white-labelled, in which case we might need a high degree of configurability and extensibility? How long do we expect this system to last overall? You may have an app that's released that maybe only be expected to last for, a few years, couple of years perhaps, before it's completely superseded, or a banking product which may have a lifetime of 10, 20 or even more years. We need to understand what the compliance and regulation issues are. Obviously, these are highly industry specific, so they need to be investigated and understood. Do we already have a system with users or data that we need to migrate away from? So, this may be an existing technical system or even a manual system where you need to have a user take-on process, for example. And then also in this area, we've included the financial aspects, as I mentioned before. How much is this going to cost to run in production? What is the total cost of ownership? And also, how much is it going to develop? Because that can act as a constraint, and we need to discuss this in our design thinking around quality attributes. Moving on to development and change. This is all around making the development of the solution for the product efficient and effective. So we're thinking about how testable, how we can make testability automated? Is it repeatable? Looking at the integration aspects of our code on the path to deployment, what's the development effectiveness, and how we're going to manage data. Looking at the runtime focus, we've really sort of split into two main areas. We've got sort of things around sort of volumes and performance, and that includes elasticity. So how responsive is our system to increases or decreases in load? How many sort of concurrent sessions or concurrent users do we need to support in this? And then the other side of the coin with reliability. So what's the availability measure we need? How are we going to manage error handling? What logging do we need to have in place, sort of auditing? And also within the reliability space, we have things like redundancy. What backup and recovery processes do we have? And then what disaster recoverability and business continuity requirements are there? So moving on to the user focus, this is really covering how usable the system is for people. So that's looking at how usable it is, how accessible it is. So does it provide support for assistive technology for people with special needs? Do we have any requirements for internationalization? Supporting other languages or other fonts or right to left display, for example. And also omni-channel. So now you may want to start a session on a PC in a web browser and then switch to an app. So that needs to be seamless. And also integration with other systems. So, for example, what APIs are we going to offer for this system? So lastly, but no means least, we're looking at security. So this includes confidentiality, so keeping information private, integrity, we need to make sure it's correct and not corrupted in any way, authentication and authorization, so that only the right people can access the right data and it can't be abused by anybody. This is a whole subject in its own right, so I'm less than scratching the surface here. So we've started to make a little bit more sense of chaos. We've got some structure around our quality attributes, but still it's a big problem. There's a lot of elements identified there. So we're really looking to do just enough work on quality attributes. And that means we need to understand what's needed at the right time, because if we start to do too much work too early, then it's wasteful because we may not have enough information. But if we leave it until too late, it means rework. And depending on the quality attribute, that may be a significant amount of rework. For example, if I forget about the requirement for logging, potentially until I've already developed a lot of code, I might need to go back and touch every single piece of code that we've already developed to put that in place. Something we want to avoid, of course. But most quality attributes, really, they're a bit like hygiene factors. There's similar types of measures required on the same types of projects in the same types of industry, and more won't make the product itself any better. We need to do something that's, good enough for this particular product. So what we're trying to understand is the quality attributes that are going to make a difference to the product itself. And we call those the critical quality attributes. And these make a fundamental difference to how the solution is delivered. And these are what's really going to differentiate between the success and failure of your product based around quality attributes. So to successfully identify your critical quality attributes, the product owner needs to understand the consequences in business terms, really, because, 5 nines availability may not mean anything to them whatsoever. So we need to start to talk in terms that they're going to understand. So, for example, security failures, they're going to lead to loss of revenue, loss of personal information, loss of IPR of the organisation, maybe a breach of customer trust. What does that really mean to the business? Because then they're going to be able to prioritise effectively. For example, accessibility failures might lead to compliance violations, or you're going to just lose customers because they can't use your site. If you're talking about medical or aircraft or manufacturing equipment, you're looking at safety failures. Well, you're looking at injury or loss of life, which is obviously bad in itself, but also massive lawsuits ensue. Performance failures on public sector websites, that will lead to people not being able to access the benefits, probably going to lead to headlines in the newspaper and various things like that. And if we look at sort of availability and reliability failures, might lead to late payments in a payment system, or worse, all-night operational problems where everybody has to come in and try and sort out the problem. I know, because when I was working at BACS, we definitely had a few of those because we had a 2 a.m. cut-off time, and if we didn't make the payment files available by that time, then there was a knock-on effect on the clearing banks, and people just didn't get their salaries in time, and that was a big thing, a big problem for millions of people. So, how do you spot the critical quality attributes? These are often raised when you're shaping the product, when you're in early workshops, for example. They'll be raised by the business or technical seniors. There may be a USP of an organisation. We're the fastest, we're the largest, we're the most usable. Sometimes these people will be able to quote measures that they expect the product to beat. For example, we work with a payments provider, and they knew that they needed to handle 5,000 transactions per second. They weren't quite sure what they meant by a transaction, but they knew they needed to be able to handle 5,000 transactions a second. And that was helpful because we knew we were working on a really high performance system. It may be a step change from the current state. Maybe you need to deal with an order of magnitude more. Example of this was when we were working with a pensions provider. They had an existing system which dealt with 30,000 pension plans, live pension plans, and they'd sold this product to another organisation, and it needed to handle 300,000 pension plans. And pension plans are quite complex things. So this was a big change from the current state, and that helped us understand the amount of change that was needed and the areas that we needed to focus on. But we need to validate that these CQAs are real. They may not be. Sometimes you will talk to a business user and they think they have a requirement, but when you delve into it, it's not really needed or not really justifiable. For example, I was working with a very large bank on a global disbursement system, and the business user said it must be 24/7. The user interface must be available 24/7. And when I asked why or what the driver was behind that, they just said, well, because it must be. When I started to articulate what the cost of that was going to be, it would be many millions of pounds to have redundant hardware, and the fact that they were really only going to be operating under office hours, suddenly that requirement disappeared. It became a much more about just a hygiene factor and not really a critical quality attribute at all. And the other thing you need to be wary of is people saying that we have a critical quality attribute that's not really challenging, but it's because it's a problem with the current system. So this can happen if you, say, have an existing system that has a very poor user interface, very difficult to use, then suddenly, ours must be the most usable. No, they don't really need the most usable system. They just need to be it to be of an acceptable level of quality. So again, it's not really a CQA that's going to drive your decision-making process. So another useful aspect of dealing with critical quality attributes is to look for trends across verticals or system types. So security, you'll find that systems which involve handling credit card payments or medical records, where you have patient confidential data, security is very likely to be a CQA. Usability for things like shopping applications, because there's a specific problem with people just abandoning carts before they've actually managed to check out. If it's not easy to use, that tends to be a significant problem. So where we're looking at things like sports streaming sites, which are very peaky, there's an event once or twice a year where they want to stream vast amounts of data, and the rest of the year it's sort of minimal traffic. You need to focus on elasticity, so you know that that's going to drive your design decision making. So how are we going to manage these critical quality attributes? First thing you need to do is to identify them, as we've already discussed. You should put them in a short list and prioritize them. Typically, we're looking for between 3 to 5. Any more than 5 and it starts to become unmanageable, you should go back and question, are these really needed? Are these real CQAs? For each of them, you need to start to develop sort of epic scope statements that start to delve into a little bit more detail about what's needed, what areas are impacted, who the stakeholders are, so that you can go and get more information off them. These then break down into specific backlog items or guidance elements. And one of the key things you absolutely have to do is identify the measures involved. How do we know we're meeting this CQA? How are we going to monitor the achievement across the sprints or program increments? Because the last thing we want to do is to get to the end of the first delivery when we have an MVP and find that it actually is missing some of the critical CQAs. Then you'll have a huge amount of rework to recover. So for our quality attributes, we need to understand what the measures are, because if we don't know what the measures are, we don't know if we've successfully delivered against them. These measures tend to group into 3 main areas. We can have absolute requirements. So for our payment processor, for example, we may have an audit requirement which states record all updates to the system. They may be quantity based. So this would be how many transactions. So maybe we need to deal with 80 million transactions a day. And then very time specific. So maybe there's a peak second, maybe it's every second. So the statement that was requested, I quoted earlier, of 5,000 transactions per second was actually a peak second, because if you had 5,000 transactions every second, that would actually be 43 million transactions a day. We already know it's only 80. So it's really important that you record your quality attributes so that they can be used appropriately during the development of your product. And there's a number of techniques you can use for this. Sometimes you can use architecture principles, particularly for high-level guidance. They will often apply across an organisation or within a domain, and things like making sure that portability is accounted for would be a typical principle that we've seen before. Very frequently, you'll see quality attributes captured in technical epics and stories. For example, the epic level may be the product must authenticate people using it. Then that will break down into a whole series of stories For example, one might be the user must provide a valid identifier and password to gain access. Then you'd have a whole range of stories about how to manage your password, first time reset, all those sorts of things. And some aspects are better captured in a definition of done. This is particularly good for things that apply across the whole of the product. So performance, there's no one component that's going to give you performance. It's a quality attribute that applies to all your components. Audit and logging are similar in this way. However you do it, you need to make sure that they're visible and people understand what they are, because that will make it far more likely that they're going to be delivered successfully. So it's very important that your quality attributes are tested, and this is a big topic in itself. Testing quality attributes is notoriously difficult, but a few techniques that you can use to help with this are simulators. These are particularly good for device testing, where you want to test a whole range of different operating systems for phones, for example. You can use models, particularly for things like scalability and performance, because performance testing of any sort of large system is very expensive and very difficult. So at least for some aspects, you can use models to help with this. But the main thing is once you understand how you're going to do this, you need to plan it in early and not leave it to the last minute, because otherwise, if you do have a problem, you're going to have to refactor a lot of code and it's going to be hugely expensive. So I'd just like to say a few words about trade-off of design, because quality attributes will have significant impacts on some of the fundamental design decisions that are made around the products that are being developed. And some quality attributes have impacts on each other. And these impacts can be positive or negative, although in most cases it's neutral. It's worth understanding within your context what the impacts are. Some examples of this. So personalization can have a negative impact on performance or scalability because of the overhead required to capture and convert the personalized data. Security can have a negative impact on usability because of the complexities of login processes, for example, can just make the system harder to use. Maintainability can sometimes have a positive effect on availability, because if you have a highly maintainable code base, then it's less likely that bugs are introduced in production. Therefore, there's a plus side to put to availability. So these are obviously going to be dependent on your particular context, but it's just worth thinking about. So I'd like to cover some of the common pitfalls that arise when we're trying to implement quality attributes on our products. We may have edge conditions that aren't obvious. Make sure that you brainstorm and use the teams and the customer's experience to build a list of failure modes as we go through the product development. There might be quite a large gap between the test environment that you're using and the real world, the target environment. So try and do a real world test as early as possible. You don't have to do it all the time, but at least if you've done one, it's going to give you some confidence that your test environment is going to match it. Over time, the conditions or the definition of your quality attributes may change. So you need to make sure that you revisit this on a periodic basis. And of course, another aspect is that we may not actually have the resources needed to implement the whole of the quality attribute scope. This results in instant technical debt, which is something we should really try and avoid. Another thing that might occur is that decisions that are made during development by the team might not always consider quality attributes. We need to make sure that we're ready to do agile refactoring and undertake regular peer reviews along with the testing which will help to catch these as early as possible. Just to summarise some of the key points we've covered today, I think we've seen that the business impact of ignoring your quality attributes can be disastrous to the organisation, or at least disastrous for your product. But the cost and impact of too much focus on the wrong quality attributes can also be damaging to your product. So we need to find the right balance to invest in the things we identify as the critical quality attributes, and we need to make sure that everyone knows what they are and that they can be measured and tested. And this will help you deliver a successful product. I'd just like to say thank you for listening and for contributing to this session. I hope it's proved useful to you all.